This is lignite, or brown coal. It's been exploited for centuries as a poor cousin to black coal. Lignite is found all over the world. There's plenty of it. It's near the surface, so it's easy to find and easy to mine. Yet it's a bit of an orphan in the field of energy. That's because lignite contains a lot of water, sometimes over 60% water. That means two things. It's a low energy density fuel. You have to burn twice as much lignite as black coal and create twice as much CO2 for the same amount of energy. This high level of moisture also makes lignite expensive to transport. You are moving around a high percentage of water for no energy gain. So you have a low-grade energy resource that is economically stranded at or close to its point of mining. Ignite have more than an exploration right for vast quantities of lignite. They have the ability to change our view of lignite. In fact, they have the ability to change the way in which lignite is used altogether. The Ignite team is made up of experts in a range of fields. Chairman Tom Robinson is a pioneer of the gas and oil industry in the US. CEO Dr. Len Humphries has been involved in the commercialisation of technology for decades. And guiding the Ignite team of technology and chemistry experts is Dr. Thomas Maschmeyer.
Ignite has developed a new process to convert a low-value resource such as lignite into a high-value product. One of the reasons for the low value is the high water content in the lignite, and you can see even here we get condensation on this particular sample. Ignite has designed a new reactor, the world's first continuous lignite conversion supercritical reactor, which allows it to make products of three different classes. Three different liquids, medium, light and heavies, as well as a high quality char. Supercriticality is a fourth state of matter. We have solid, we have liquid, we have gas, and supercritical is yet an additional state. What it is, it's a highly compressed gas, which is so compressed that it can actually dissolve liquids and other molecules. Supercritical processing has been around for a long time. It's used in the food industry, in extractive processes, and in the power industry. Supercritical steam is often used for power generation. The carbon intensity of the lignite goes down by a factor of 2. It's only 50% of the CO2 that is emitted for the same amount of power generation possible.
Ignite has already taken this technology out of the lab and into the real world. This is their pilot plant in New South Wales, Australia, where they are using a supercritical reactor to turn lignite into fuels. Ignite believes this is the first and only continuous flow processing facility of this size to make liquid and solid fuels from lignite. Dr. Len Humphries, CEO of Ignite, will show us some of the features of the plant and tell us more about what can be done with lignite.
This is where the fusion of technology and resource takes place. This sample of brown coal comes from the Gippsland Basin. It could be very similar to what we get from EL4416, our own resource. The first step is to take the brown coal, which is this material here, and we make a slurry out of it. This is the slurrying tank. Once we've created the slurry, the next major step is to compress it and heat it. So it goes through the compression system here and the heating system. Then the slurry at supercritical pressure and supercritical temperature leaves here and goes outside to the reactor. The lignite slurry now enters the base of the reactor. At this point, the slurry is at a supercritical point. This is the point where the normal problematical water to lignite or brown coal becomes the agent of change. The supercritical water breaks apart the lignite, forming the three products from the lignite process, which are the oils, the chars and the gases.
Chemical engineer Adriana Downey can tell us more about these products.
Independent analysis of the liquids produced from the Ignite process have shown that they can be used for an array of purposes, from blending with transport fuels and feedstocks to synthesizing into plastics. We're also producing a range of specialty chemicals which have higher market values. The remaining solid is a high quality carbon, or coke. The high carbon content of this material has been analysed independently and shown to have uses such as a coking coal replacement or as an activated char for agriculture and industry.
With the welcoming market for this product, the next step for Ignite is to establish a commercial demonstration unit at Somersby. Why hasn't this been done before?
You can consider it of how oil sands were looked at in the 70s. They weren't conceived as any form of energy, they weren't conceived as any form of oil. Today, oil sands are probably the second most valuable source of oil on the planet. The Ignite process unlocks brown coal, like in the early 70s, processes developed then in the 80s unlocked the potential of oil sands.
What type of yield and pricing are you anticipating for the products?
The Ignite process, what the independent experts have viewed it from, is if we start from a dry ton, that dry ton will produce 60% high value coal and it will produce 30% high value oils. So you flip that around, what we get is for every ton of dry coal we would work on, you produce 600 kilograms of high value black coal and we produce 300 kilograms of high value oil. In terms of pricing, what's the value of those products? Conservatively, it's been estimated by these independent experts that the black coal could be sold for at least $300 per ton and the oils from a range of $800, and if we decided to separate some of those oils, there's some very high value components in there that could be of $1,000 and beyond for those fractions.
So there's a significant margin there?
Absolutely. Our process can turn something that's a very low value product into a very high value group of products. So the two interesting things about our plant is the reactor is proprietary, but the scale up to commercial scale is only less than 50%. Secondly, the balance of equipment that we use for the plant is available anywhere on the planet. So what that means is we can get support, we can get service from agents and manufacturers wherever we are in the world. With the Ignite modular approach, that module is capable to be shipped anywhere around the planet. But it's also scalable. So if I put 3 of these modules together, I can create a plant of processing 30,000 tons a year of slurry. If I put 10 of these together, I can create a plant that processes 120,000 tons a year of slurry. At the present time, our reactor, our pilot scale reactor, has a diameter of about 3 inches. In our process scale, we're going to do that in a modular form. Essentially, we're going from a pilot scale of about 3 inches up to a full process modular scale of about 4 inches, which is only a 50% scale up.
While the impact of our high-valued carbon product on the coal industry will be significant, the impact in the oil industry may be even more substantial. With our ability to turn 1 ton of lignite in the ground into 1 barrel of oil, we can turn a coal field into an oil field. When oil companies realize that they may be able to book oil reserves on a coal field, that will have a dramatic impact on their business. With our 18 billion tons of proven resources in the Gippsland Basin, we will potentially be able to book 18 billion barrels of oil and 5 billion tons of high-value carbon products.
Lignite has come a long way from the mine, and thanks to Ignite, it's got even further to go.
By combining an Australian-developed technology, Ignite, with an Australian-based lignite deposit in the Gippsland Basin, we're able to create a clean, secure, and abundant energy source for Australia and the world.